Recording in progress.
So for hydroxides, when heated, it decomposes into water and oxide. So that means that whenever you see a combination with element plus hydroxide in the reactant, nothing more, is going to be decomposed into water and oxide. Now the oxide is going to depend on the metal that is part of the reaction. Take a look to this example. I have here KOH, or as we know as potassium hydroxide. Okay, we have potassium hydroxide, and because it's only one compound, decomposition will occur. It will produce water, according to the rule, will produce water and oxide. But what kind of oxide? As I told you, the oxide is going to depend on the metal that is part of the reaction. In this case, the metal is potassium. So the product will be potassium potassium oxide. Okay, that is going to be the product. Sorry, it's not updating. Guys, do you listen to me?
Yes, Miss.
Okay. I'm sorry, this is not updating. Mhm. Yeah, now it is. Okay, now it's good. I'm sorry, guys. It's the I don't know. I think it is the connection. So have to start again. So it says whenever we have a hydroxide, it's going to produce water and an oxide. The oxide, as I was telling you, is going to depend on the metal that is part of the reactant. In this case is potassium. So the product is going to be potassium oxide. Now for potassium oxide, you're going to have this potassium, which has a charge of +1, and oxygen that has a charge of -2. You're going to crisscross the charge, and in the end, the products are going to be H2O plus K2O, because this 2 is the one that is coming from oxygen. So whenever you see a compound, a whole compound in a reactant alone, okay, and it has hydroxide in it, it's going to produce water and oxide. And as I told you, the metal in the oxide is going to depend on the metal in the reactant. Of course, when you crisscross the charges, remember that you will crisscross only those that are different than 1. Charges of 1 are going to be ignored. You don't need to crisscross charges of positive or -1. Now, let's take a look to this another example. It says iron 3 hydroxide. It is written in words. Okay? Iron 3 is nothing more than iron with a charge of positive 3. Okay? And hydroxide, as I told you, it is an ion, OH, and it has a charge of -1. So the charges of 1 are going to be ignored. Okay, they're going to be ignored, but you will crisscross only the ones that are different than 1. Okay, so in the end, iron 3 hydroxide is FeOH, and this 3 that is coming from iron. But remember a rule that I told you the other day. Whenever you crisscross a charge to a polyatomic ion, you have to include parentheses. If you do not include parentheses, it's going to be incorrect. Okay? So here the charge of 3 comes to the other side, but because hydroxide is polyatomic, you're going to place it in parentheses. Now, what is this going to produce? Because it is hydroxide, I know that it's going to produce water, I'm sorry, I'm going to write it in words first. Iron 3 hydroxide. According to the rule, will produce water and oxide. What kind of oxide? It will depend on the cation. The cation is iron 3, so the product will be water plus iron 3. So now we're going to turn these words into formula equation. Water, you know the formula is H2O, and iron 3 oxide is going to be iron with a charge of positive 3 and oxygen with a charge of -2. Because the two charges are different than 1, you're going to crisscross the two of them. Okay? So in the end, the product form is iron, this 2 that is coming from oxygen, and this 3 that is coming from iron, sorry. So this is the procedure. I'm gonna put it apart, but this is the answer. Remember, the procedures are needed, okay? That's your final answer, but the procedure is required. I'm showing you the procedure needed to obtain iron 3 oxide. Now, this is the first part, okay? You already know what is going to be produced. If you do this, you're gonna get half of the point, okay? But now you also need to balance. Balancing is the rest of the procedure. So for balancing, you need to list the elements, and you will perform the procedure of balancing. You have 1 iron, 3 hydrogens, 3 oxygens in the reactant. In a product, you have 2 irons, 2 hydrogens, and 1 plus 3, 4 oxygens in the product. So as you can see, the equation is not balanced. To balance, I need to put 2 in front, and my iron now is going to be balanced. But that 2 is going to affect not just iron, but also oxygen and hydrogen. Okay? So my hydrogen is 2 times 3, 6, and the oxygen the same. 2 times 3, that makes 6. because I need to balance. Okay, my iron is balanced already. I continue with hydrogen. To balance hydrogen, I place 3 in front, so I have 6 hydrogens, and this changes my amount of oxygen. Now I have 3 oxygens in one side and 3 oxygens in the other side, but in total I have 6 oxygens, and because all the numbers match reactants and product, now I say that my equation is balanced. So the part of predicting product is just this, okay? But this part, the balancing procedure, is also part of your procedure, okay, of your full procedure. So you have to do both in order to get all the points in the quiz. Analyze this exercise and tell me if you have a doubt. Xavier?
Miss, can you remind me why in oxygen in the right is triple is one plus three, right? So it's four, and then is three plus three. Can you remind me why four
Uh,
is
okay, yes, let me show you. It was 1 plus 3 initially, okay, so I had 4 initially, but then I have 6 because this 3 from here multiplies the 2 from hydrogen. So this gives me 6 hydrogens. But also that 3 is going to multiply your oxygen. Remember that oxygen is invisible 1. So 3 times 1 plus invisible 1 times 3 that you have in the other side. Okay, here we have an invisible 1. Okay, so here you're going to have 3 and 2, 3 and 1 that makes 3, plus 1 and 3 that makes 3. In total, I get 6. That's how you get a 6.
Thank you.
Okay. Is there another doubt about the exercise? Okay, since there are no doubts, I want that you try with this exercise. In this moment in your notebook, predict the product of now. Remember to follow the rule, okay? The rule is water and oxide, the product. So predict the product and do not forget to balance. Once you have the answer, you send it to me in the chat. Once you have the answer, send it to me in the chat. Okay, any other student that did the exercise who can send me the answer? Guys, you need to participate more. When I ask you to try, it's because I concerned about if you are understanding the topic or not. If you send me anything, I don't know if you are at least trying. Very good. Freddy and Dulce, those are the good answers. Okay? Thank you for your participation today. Um, for those who are doing that exercise, according to the rule, you should obtain water and whatever oxide, okay? Because we're talking about sodium, so it's gonna produce sodium oxide in the end. And all I do is, well, forming the formulas. Sodium, which is Na1 plus, and oxygen oxide, that is O2 minus. This charge will be ignored while this one is being crisscrossed. So in the end, this is what I get, okay? And what I do after is checking that it is balanced. So NaHO, I have one of each in the left, and I have two of each in the right. So because I have all ones and I need twos, I am going to multiply times 2, and from here everything will be balanced. That's all you have to do. It didn't require too much time. Guys, you are not participating. Participation is important. This is the only way that I can tell that whatever we are seeing, you are putting into practice. Do you want me to explain another example of this? Send me the answer by chat, or just raise your hand if you prefer like that. Do you want another example? Thank you, Xavier. Anyone else?
Miss,
Uh-huh.
I just gotta say that in this exercise, I did it a little bit different. Maybe I think that I did it bad because in the last part, in the part of sodium and oxygen, I
Uh-huh.
didn't write the two behind sodium, so I write it in the left, and that's the way I got two sodium and two oxygen.
You write it here, like that, or here.
No, no, I didn't write it.
Ah, you
I
didn't
just
write it, just NaO. Yeah,
yeah,
that will be incorrect because at the moment that you are balancing, it's going to give you a different result. Though the prediction of the product, it could say that it's not entirely wrong because it is a combination between sodium and oxide. So for a mistake like that in a quiz, I will give you half of the points. It will be incorrect, yes. So yes, you're saying another example. So take a look to this example that I will do right now. I'm gonna write it in words. Nickel 3 hydroxide. I will do 2, okay? And nickel 2 hydroxide. That's what I have in words. And I need to predict what is going to be the product, okay? Because I see hydroxide, I know that I will produce water and whatever oxide. So water plus whatever oxide, okay? It's going to be my product. I just want you to see the difference between the two. Okay. So, because we are talking in this exercise, we're talking about nickel 3. What I'm going to write here in the whatever part will be nickel 3. Remember, we write the cation and we keep the charge from the exercise. Also in this part, nickel 2 is my cation. So that's what I'm going to write. So this is the prediction of the product, but I need to translate these words into formula. So for nickel 3 hydroxide will be nickel with a charge of 3 plus and hydroxide with a charge of 1 minus. Okay, the charge of 1 minus, I will ignore it. Okay, I will just crisscross the 1 of 3. And because I have a polyatomic ion, I need to include parentheses. I'm gonna leave the procedure there, but the compound form is nickel OH 3 and to separate parentheses. In the product I have water and nickel 3 oxide. That is basically the same procedure, nickel, a charge of 3 plus, and oxygen that is 2 minus. The two charges are different than one, so they're going to be crisscrossed. And in the end, the product form is nickel, 2 from oxygen, oxygen, 3 from nickel. Okay? Again, the procedure, I write it beside. And I do after, what I do is balancing. Okay? I'm not going to balance, at least not explaining it. I'm going to do now the other procedure. For nickel 2 hydroxide, nickel 2 will be NiOH2. Okay, because it is nickel 2. So the number that is being crisscrossed is the 2. In the product, you will get water and nickel 2 oxide. Nickel 2 that is like this, and oxide that is like this. So when you crisscross, actually you don't need to crisscross the charges because they are gonna be canceled. And you will notice that this exercise is going to be balanced already. Okay, when you compare, it's gonna be balanced. The other one above is not, so you have to balance it, and that's exactly what I'm gonna do now. Here I have 1 3 3, and here I have 2 2